Here's part 2 of the neutralization reactions, and we're going to finish this. Hopefully you've had a chance to go through each of these. If you're still having trouble, we're going to walk through these and go through each of the steps, step by step. So we're going to try to write a balanced equation for this, and again we need to start by putting in the charges. Remember, H is always going to be plus and OH is always going to be minus. We're actually looking for what's the charge of the other ions. Well, if you do the reverse crisscross right here, you'll see that the CO3 for the polyatomic ion is going to be A2 minus. In strontium, you can either look at a periodic table or you can just do the reverse crisscross to see that this is going to be a 2 plus charge. Okay, so we're reacting these together. And if you remember, we're going to be creating waters. The question is, how many waters are we going to be creating? So we have H2O. Remember, what creates the water is going to be an H plus and an OH minus. How many H's do I have? I have 2. How many OH minuses do I have? I have 2. If one H and one OH makes one water, 2 H's and 2 OH's are going to create 2 waters. So let's see the salt that is created. So the salt is created from the positive ion and the negative ion that's left over. So the positive ion is going to be the strontium with a 2 plus charge. And we're also going to have a carbonate, CO3, with a 2 minus charge. Do I need to do the crisscross on this? And the answer is no, because they are already balanced in their charges. This next one's going to be the most complex of these three. So we're going to be creating water, and that's formed from the H plus and the OH minus. Let's do the reverse crisscross. The charge of the calcium is going to be a 2 plus. I have 1, this is going to be a minus. Remember, the charge of the H is always going to be plus. OH is always going to be negative. Here I have a 3. So the PO4, the phosphate's going to have a charge of 3 negative. So the question is, how many H's do I have? I have 3 H's. How many OH's do I have? I have 2. Well, that's not going to balance. So what's going to be the reconciling factor between 2 and 3? I'm going to have 6 waters. Well, in order to have 6 waters, what do I have to multiply the 3 by? I have to multiply this by 2. What do I have to multiply the 2 by? I have to multiply it by 3. So that means over here, I'm going to need 2 of the H3PO4s to have 6 H's, and I'm going to have 3 of the calcium hydroxides to have 3 times 2 OH minuses. With that in mind, we can now create our final salt as well. We're going to write the positive ion and then the negative ion. Okay, we used the H for this and the OH, so it's the remaining ions. So we're going to start off with the calcium. Okay, the calcium has a charge of 2 plus. The phosphate has a charge of a 3 minus. And when you do the crisscross, you'll note that it's going to be 3 calciums and 2 of the phosphates. However, since I have 2 of the PO4s, this is a polyatomic, so I'm going to need to put my parentheses around those like that. Now let's check. I have 3 calciums on the right. I have 3 calciums on the left. I have 2 phosphates on the right. I have 2 on the left. So in case if you had difficulty finding out how many waters there were supposed to be or what these coefficients were supposed to be, you can also figure that out by creating your legal salt with the correct subscripts, and then you can go back and put them over here to determine how many H's and OH's and how many waters that you need. So we're going to follow similar steps to produce these compounds over here. So we're going to be creating waters. So how many waters will I create? By combining H pluses and OH minuses. I'm going to have 2 of the H pluses. How many OH minuses do I have? I have 1. Let's put the charges in here real quick. Again, it's positive and negative for the H is always going to be positive, OH is always going to be negative. And when I do the reverse crisscross will show that my CO3 is going to be a 2 minus. This is going to be just a plus like this. So first of all, 2 and 1, the reconciling factor is going to be 2. Well, I have 2 H's. That means I'm going to have 2 OH minuses. So I'm going to have to come back here and put a 2 right there to get my 2 OH minuses so that I can have 2 H's to combine with that to produce the 2 waters. So now let's create a legal salt over here. We have the cesium that has a plus charge, and we have a carbonate, the CO3, which has a 2 minus charge. If we do the crisscross, that's just going to be a 1, but this is going to be a 2. And notice that we have the 2 cesiums here. We're going to have the 2 cesiums there as well. So that's a way to check to make sure that we've balanced everything correctly. The name of this salt is going to be cesium. And you should know CO3 from your lecture notes. This is going to be carbonate. Similar process down below here, where we're going to be creating H2O, creating water and a salt. So we have the H pluses and OH minuses. How many H's do I have? 1. How many OH's? I have 2. The reconciling factor of 1 and 2 is going to be 2, which means I'm going to need to have 2 H's. So I'm going to go back here and I'm going to put a 2 as a coefficient. Let's do our charges. H is always going to be plus, OH is always going to be negative. Reverse crisscross will show that this is going to be a charge of negative. Reverse crisscross will show that the magnesium is going to have a charge of 2 plus. Let's go ahead and create my salt with the positive ion first. The positive ion is going to be magnesium with a 2 plus charge. The negative ion is going to be fluorine with a negative charge. Those are not balanced, so I have to do the crisscross, and this will show me that it's going to be MgF2, which again, to check, this is going to say that I'm going to need 2 fluorines, and I have 2 fluorines on the other side as well. The name of this salt is going to be magnesium fluoride, for the magnesium and for the fluorine. Okay, last one on this page, very similar to the other ones, and well, we're going to be creating waters. The question is, how many waters will we create? Again, we have H plus and OH minus. How many H's do I have? I have 1. How many OH's? I have 3. Reconciling factor between 1 and 3 is going to be 3, which means I'm going to require 3 hydrogens. So if I put this over here, I'm going to need 3 of those. Let's put my charges. Hydrogen is always positive. Hydroxide is always going to be negative. Reverse crisscross shows that this is going to be a negative charge. That aluminum is going to have a charge of 3 plus. Let's go ahead and check. We have 1 aluminum here, 1 aluminum here. We have 3 nitrates, 3 NO3s, and we have 3 NO3s on the other side as well. So it looks like that this is now balanced, and the name of this is going to be aluminum nitrate. On the next page, again, we're trying to create what the acids and bases are going to be. Acids always begin with H+. Bases always end with OH-. And based upon the salt, we can work backwards by taking this apart. So let's take a look at the charges. The zinc is going to have a charge of doing the reverse crisscross, 2+. The NO3 is going to have a -1 charge. What's the charge on the aluminum? 3+. How many aluminums do I have? I have 1. So the charge on the ClO, or the chlorate, is going to be A-. Okay, here we have a polyatomic ion. We have NH4, which is the ammonium ion, and we have iodine, or iodide. Okay, how many iodines do I have? I have 1. Therefore, the charge of the NH4 is going to be a +1. How many NH4s do I have? There's no parentheses around them, so I just have 1. So it's going to look like this. Let's now go ahead and put our charges, or our remaining ions, when we split these up to work backwards to see what the acids and bases were. So zinc, the 2+, is it going to go with the H or the OH-? The zinc with the 2+ will go over here, and the nitrate with the NO3- will go here. These are balanced charges. These are not. So I have to do the crisscross. There's 1 of the zincs. There's going to be 2 of the OHs. So if we split this salt up, we have the aluminum with a 3+. The aluminum with the 3+ goes here. The chlorate, the ClO with the minus. So actually, this is the subscript, so we're going to create a legal compound. And there's only one of those. We actually wouldn't need those parentheses. However, on the other side, when we do the crisscross, we will need a 3 there. Now the NH4 will be over here with the plus, and the iodine will be on the other side with the minus. They have the same charge, nothing's needed. They have the same charge, nothing's needed. That's it. To summarize, when you're getting the charges, you do the reverse crisscross. And for your acids and your bases, you're going to be using the crisscross.